For most of human history, when we looked at planetary systems, we only had one example to go by, our own. So, naturally, we figured we were the blueprint for the entire universe. But in just the last few decades, everything we thought we knew has been completely turned on its head. So let's dive in and figure out where our solar system really fits in the grand cosmic neighborhood.
And that's really the big question we're tackling, isn't it? Is our home, our solar system, just a standard issue model for how you build planets around a star? Or are we living in some kind of cosmic oddball, a weird, rare exception to the galactic rule? Well, the answer is a lot more surprising than you might think.
See, we had this really neat and tidy theory, a beautiful model that explained everything we could see. The only problem was, we could only see what was right in front of us. And the moment we started looking further out, we realized the universe has a much wilder imagination than we ever gave it credit for.
Okay, so let's start with that old blueprint. For centuries, our solar system was the only game in town, and it gave us a very specific, very orderly set of rules for how a star system should be built.
It all seemed so logical, so perfect. You've got your small, dense little worlds like Earth and Mars, huddled up close to the sun's warmth, and then way out in the cold, you've got the giant, gassy planets like Jupiter and Saturn reigning over the outer depths. Everything in its proper place, all moving in these calm, predictable circles. This, we thought, was the template for everyone.
And then this happened. 51 Pegasi b. Imagine a planet about half the size of our Jupiter, but it orbits its star in just 4 days. It was a gas giant, but it was scorching hot, way closer to its sun than Mercury is to ours. This one single discovery didn't just bend the rules, it threw the entire rulebook out the window and opened the floodgates.
With that one discovery, we stepped into a brand new era. We could finally peek into the other houses in our galactic neighborhood, and what we found was just this stunning, unbelievable collection of strange and unexpected worlds.
And the numbers just keep going up and up. We went from a sample size of one solar system to a catalog of over 6,000 confirmed planets orbiting other stars. For the very first time, we have enough data to do a real comparison, to actually see where we stand in a galactic lineup.
The first type of weird world we found were these hot Jupiters, and they are absolute cosmic monsters. These are gas giants on orbits so tight they completely defy the old logic. Our theories said they shouldn't even be able to exist that close to a star, but there they were, all over the galaxy.
And then we started finding these things, super-Earths. They're planets bigger than Earth, but smaller than Neptune. And it turns out this is the single most common type of planet in the entire Milky Way. They are literally everywhere you look, except, as we're about to see, in one very important place.
And here's the kicker. The galaxy's most common, most popular model of planet is completely missing from our own solar system. We go from the little rocky planets like Earth straight to the absolute behemoth that is Jupiter, with nothing in between. This is our first huge clue that, hey, maybe we're the weird ones.
And the weirdness just keeps piling up. A lot of the systems we're finding out there are incredibly compact. They'll have a bunch of planets all crammed together in orbits smaller than Mercury's. Our system, on the other hand, has this enormous empty space in its inner region. We're spacious, we're spread out, almost peaceful compared to what seems to be the chaotic norm.
Okay, so let's actually break this down with a proper scorecard. Now that we have thousands of other systems to compare ourselves to, we can finally get a clear picture of where we're totally average and where we are just profoundly strange.
So in some ways, we're pretty normal. Our sun, a pretty typical middle-aged star. Jupiter and Saturn, standard-issue gas giants. And having 8 stable planets? Yeah, that fits right in. But on the weird side of the ledger, oh boy. Our entire architecture, small planets in, big planets out, is bizarrely uncommon. The fact that we have no super-Earth is a massive statistical anomaly. And that huge empty space near our sun is a major outlier.
This chart really drives the point home. A full 80% of systems out there have planets of a similar size all mixed together. Our ordered structure, where planets get bigger the further you go out, that accounts for a tiny 2%. We're not just uncommon, we are in the absolute rarest class of planetary systems ever found.
And let's just put a fine point on this. 0. That's the number of super-Earths we have. The galaxy's most common, most frequently produced product, and our system didn't get a single one. This isn't just a little quirk, it's one of the most defining and strangest features of our cosmic address.
So you might be thinking, okay, we're weird, who cares? Well, it turns out that our weirdness might be the most important thing about us. The evidence is starting to show that our system's statistical rarity might be the very reason we are here to even talk about it.
Let's just look at the benefits of being an outlier. That big empty space near the sun, it meant a small, fragile, rocky planet like Earth could form without getting bullied or tossed out of the system by a larger neighbor. And having a giant like Jupiter way, way out there, it acts like a cosmic bodyguard, a gravitational shield that protects us from a constant hailstorm of comets. In those calm, nearly circular orbits, they've given Earth billions of years of stability, the uninterrupted quiet time that complex life needs to evolve.
So let's bring this all together. Let's really define our unique place in the universe. Because the conclusion? Well, it really changes how you see everything.
After sifting through all this incredible data from thousands of worlds, scientists have come to a pretty stark and amazing realization about our status in the galaxy. We are the cosmic 1%. Systems with our specific architecture, especially with a big gas giant like Jupiter in a distant, stable, circular orbit, are estimated to make up only about 1% of all planetary systems out there. We're not average, we're part of an elite club.
So think about that journey. We went from assuming we were the universal standard, the boring template, to discovering that we are rare, precious, and maybe even finely tuned exception. Our calm, orderly home is not the norm in a galaxy that appears to be, for the most part, incredibly chaotic and violent.
And that leaves us with a final, massive question. If the kind of calm, stable, protected home that allowed life to flourish here is so exceptionally rare, what does that mean for the search for life elsewhere? It suggests that finding another Earth might be even harder and ultimately even more profound than we ever imagined.